Ibrahim have asked a question. Again, small quick review. What is the difference between exothermic reaction and endothermic reaction? When I say endothermic reaction and exothermic reaction, it means two things. Exo means input energy requirement is less. Is less. And the most important part is output energy released is more than the energy provided. In other words, you can say that this reaction, exothermic reaction, can be used to generate energy because output energy will be more than the input energy. Like this exothermic reactions, as I already told you, fission reaction can be used to generate electricity or energy that can later on use for electricity. That is exothermic reaction. Endothermic reaction, like fusion reaction, input energy is so much big. Like you have to provide so much energy to actually perform that reaction. Output energy is released as well, but output energy is less than the input energy. So in other words, in exothermic reaction, input energy is less than the output energy, and in endothermic reaction, output energy is less than the input energy. Yes, Ibrahim. Any confusion?
No, sir, I got it.
You got it. Now, in the last class, we have written something related as half-life. Now, what exactly is half-life? Let's discuss it. Today, we try to finish this chapter. Half-life is a term used to actually showing few things. We already seen that radioactive elements continuously radiate radioactive materials like alpha, beta, gamma rays, and they continuously decay, or you can say they continuously change into other nuclei, like nitrogen changing into carbon or carbon changing into nitrogen, something like this. My question is, how do you know that in how much time, how much material is decayed? For that reason, we use the term called half-life. It means that time period in which half of the element or a half of the material is decayed. Let's suppose, let's give it an example. You got 50 gram of uranium. Now, if you want to see what is uranium half-life, you will see what will be the time that 50 gram reduced to 25 grams. In other words, out of 50, 25 gram of the uranium will be decayed. That will be the half-life. So whatever half-life of a radioactive isotope is time it takes for a number of nuclei of isotope in a sample to half. Whatever, if the number of nucleus, you know that, nuclei, you know that, when they become half of their quantity, that time period is called as half-life. Like I'm asking a question, let's suppose an isotope got 3-day half-life. If I have 50 grams of some material whose half-life is 3 days, after 9 days, how much grams are left? Yes. Who will tell me this? 3 days is the half-life of a material whose gram is given as 50 grams. After 9 days, how many grams of that material left? Very simple. In 9 days, how many half-lives are passed? 3 days single half-life. So what you do, number of half-life, there is a formula. Total years or days, whatever, divided by the half-life, which is 3 in that case. So we got 3 half-life. It means 3 times your mass will be divided by 2. So first time 50 reduces to 2 becomes 25. Then 25 reduces to 2 becomes 12.5. And the third one is 12.5 reduces to 2. It gives you 6.25. So the actual material left behind after 3 half-life will be 6.25. Guys, do you understand this?
Yes.
Good. So basically, in half-life, if I use the word count rate, don't be confused, it means the same. Activities means the same. As the number of atoms reduces, activity also reduces. If there are more numbers, more activity. So sometimes we do call it activities. Number of nucleus decayed is named as the activity. So what is the formula? Formula will be amount of substance divided by 2 raised to the power number of half-lives, amount left. I want you to write this formula. We will use that formula because this formula will be used in this chapter in these last questions. How do we use it? Let's see. First, copy this. Now, let's suppose this is a question. They say that the graph shows how the count rate from a sample containing the radioactive material of 60 carbon, cobalt 60 changes with the time. Can anybody tell me any ideas? What is the half-life of this cobalt 60 by only looking at the graph? Approximately. How many years? Yes, who will tell me? If you check it out, when that experiment started, total number of atoms left were 220. So now check it out how much time it takes to reduce this 200 by 100. So let's see, let's see, let's see. This is the point where 200 reduces to 100. Check it out. It's approximately 5.2 years. So the half-life of that material is 5.2 years. The time it will become half of its quantity is called as time period. Guys, understood? Okay. Now check this question out. They say that, I want you to copy these questions from here. They say that an isotope of cesium CS137 has a half-life of 30 years. If 1 gram of CS135 disintegrate over a period of 90 years, how many grams of cesium 137 would remain? Now, in these kind of question, you first write the data. The half-life is given, which is 30 years. If 1 gram of cesium disintegrate, it means amount of substance is given. And the total time is given. They are asking you to find out how many grams of cesium remain. Now, if you see the formula, how many things are known? You know the amount, You know the number of half-lives. You do not know amount of left. Now, how will you find out the number of half-lives? In 90 years, how many number of half-lives are there? So, number of half-lives is equal to total time, which is 90 in that case, divided by 30, which is equal to 3. So, number of half-life is 3. Now, place the value. Substance is 1 grams. Formula is 2 into power 3. That will give you amount left. So, this is basically 1 upon 8. What is 1 upon 8 equal to? 0.125. It means after 90 years, that substance will left as 0.125. So B is 100% right. Guys, understood?
Yes, sir.
Ibrahim, Safiullah,
Yes.
Armina,
Yes.
good. Copy this and try the next part. Question number 2. Selenium 83 has a half-life of 25 minutes. How many minutes would it take for 10 milligram of a sample to decay and only have 1.25 milligram of it remains? You have to use the same formula, but let's see how do you do this. Question number 2. Formula will be the same, but how will you use it? That's important. By using this formula, you can very easily find out the number of half-lives. Let's check this out. They have given you 10 milligrams and they say reduced by 1.25. So basically, amount of a substance is given. 10 milligrams. Amount left is 1.25 milligrams. And they say half-life is given 25 minutes. What they're asking you, how many minutes would it take to? So how many minutes? That's what is required. Use this formula and check what can you find out. So move this 2 to the power number of half-lives here. Number of half-lives is equal to amount of a substance, which is 10 milligrams, divided by amount left, which is 1.25. What is the value 10 divided by 1.25? Yes, 10 divided by 1.25. How much?
Sir, 8.
8. So your 8 is the value coming up. Now, how can you find the total number of half-lives? Make this age as equal to 2 to the power something. So we know that 2 to the power 3 is equal to 8 actually. So n is equal to 3. It means there will be 3 half-lives altogether. Each half-life is 25 minutes. So 3 half-life will be how much minutes? 3 multiplied by 25, which is equal to 75 years. 75 minutes. It means that in 75 minutes of time, 10 milligram of substance will reduce to 1.25 milligram of substance. So your answer is 75 milligram. In the end, you just need to multiply it with half-life. See, this is the formula you have it. Now, 2n is equal to amount divided by amount left. So how much amount you have it? 500. So 500 divided by 62.5, which is equal to 2n. Ibrahim, what is the value coming up, beta?
8.
8. Now 2n is equal to 8. So basically 2n is equal to 2 raised to the power 3. It means the number of half-lives are how many? 3. 3 times your material become half, right? Now this is the total time. Total time. So half-life means 24.3 divided by 3. So what is the value coming up?
Um, 8.1.
8.1. This is your half-life. So sometimes you have to multiply because half-life should be smaller than the total numbers. Okay? Safiullah, any problem?
No.
And what about you, Ibrahim? So this is the first one, A. Okay, guys. What is the half-life of plutonium 214 if after 820 seconds, a 1 gram of decay, 1 gram of sample decays to this much? Any one of you found out what is the half-life of plutonium?
164.
164. What about others?
Sir, I got 164.
And what about the other? Let's quickly see that. What is the half-life of plutonium if after 820 seconds, 106, I mean, 1 gram of sample decayed to, now same formula, amount is 1 and it decays to 0.03125 and that is equal to 2 raised to the power n. Can you tell me what is this value coming up? 1 upon 0.03125?
32.
32. So 2 to the power n is equal to 32. It means that 2 raised to the power 5. So total number of half-lives are 5. This is 820. So half-life you have to find out is 820 divided by 5. So what is it? 164. You have to divide it by 2. So the answer is 164. Absolutely right. Bang on target. Okay, try this one. Half-life of Zn71 is 2.4 minutes. If one had 100 grams at the beginning, how many grams would be left after 7.2 minutes have elapsed? Yes, any one of you?
12.5.
12.5. Okay. Any one of you? Any other? Safiullah have done this. Let's see the formula. Amount divided by 2 raised to the power n is equal to amount left. Okay. So amount is how much? 100 grams. And the half-life of Zine is given as 2.4. And how many grams would be left after 7.2 minutes? Now, number of half-lives. How will you find number of half-lives? 7.2 divided by 2.4. What is this value? Yes. What is the value? 7.2 divided by 22.4.
3.
3. So it means the total number of half-life is 3. So 100 divided by 8 is equal to 12.5. Is that the answer of you people? It's 12.5 left. See that?
Yes, sir.
So basically, you will left with 12.5 grams. One more question and that's it. PD100 has a half-life of 3.6 days. If one had 6.02 into 10 raised to the power 23 atoms on the start, how many atoms would be present after 20 days? If half-life comes in decimal, no problem. Keep the half-life in decimal, no issues. Amount divided by 2 raised to the power n is equal to amount left. So what is your amount? 6.02 into 10 raised to power 23 atoms divided by. Now, number of half-lives. How will you find the half-lives here? Number of half-lives?
20 divided by 3.6.
Yes. So what is it?
5.5.
Yeah, 5.5. So basically the formula will be 6.02 into 10 to the power 23 divided by 2 raised to the power 5.55. What is the value coming up? 1.28 into 10 raised to the power 23. Is that the answer?
No.
Is it not the answer? Formula is same, by the way. 2 raised to the power.
Sir,
Yes.
I got 1.88125 times 10 to the power of 22.
Nearly there, right? You're nearly there.
Yeah. Yeah.
That's fine. If it's 1.28 into 10 raised to the power 22 or something ahead in a sign, that's not an issue. At least you got you get the values, right? So this is the way we have done the question. So I believe everybody understood this topic, half-life. Any problem in this topic? Anyone? So inshallah, tomorrow, I mean in the next class, we may do one more topic, that is nuclear reactor, or we may start with a new chapter, that is magnetism. Let's see what we will do. If we start with a new chapter, I will leave nuclear reactor as a theoretical topic for the end. But let's see. I think we better start with magnetism in the next class. Okay. So inshallah, see you in the next class then. Take care, everyone. Allah Hafiz.